لسه ما حدثت. I will let you know. So basically, we'll talk about the meter exam. It will be Thursday, November 18th. We would like to start at 5:30. That is time that I will explain. No can complete. Okay, so if I don't receive anything from you by today or so, this will be the final. It will be 5:30. So last we started talking about a relationship between ecosystem. Relationship between two random variables, and we defined what we call the correlation. We defined what we call the correlation. The correlation was defined as the second moment, which is M11. So basically, it's expected value of x multiplied by y. We call this as a correlation. And we try to explain that it gives you how much similar x and y, how much they vary similarly with each other. So if they vary similarly, if we go large together and go small together with the same direction, then basically Rxy will be not positive or negative. If x positive if x and y vary together, proportional. X and y and negative y minus y vary together will be, in this case, the correlation will be negative, and it will be very small number, close to 0. X and y have no relationship. So if x becomes large and y becomes smaller, okay. So we define this if x the correlation as expected value of xy, and we call it as Rxy, which is the first moment of the second order. Sorry, second moment is second joint moment, which is M11, expected value of xy. And we see that if this expected value can be decoupled by the product of expected value alone, x, and multiplied by expected value of y, then we call this uncorrelated. We defined the concept which is we call it independence. However, independence is a stronger version of correlatedness. Independence means that the joint PDF decouples into the product of the margin. This is a very strong notion. However, the uncorrelatedness is much deeper and doesn't know if you say two random values are independent, are uncorrelated, and joint PDF ولا another even know the PDFs. However, what we did is we tried to verify whether the expected value of xy decoupled into the product of the two units. In this case, they are uncorrelated. So we say that independence is a stronger version. If two random values are independent, then the joint PDF decoupled into the marginals. In this case, this will lead to the expected value of xy will be equal to the product of the two expected values. But if they are uncorrelated, so if they are, and we said that, we put it in what will be like this? I didn't type it. So two random values are independent. It means they are uncorrelated, right? Well, uncorrelated. However, uncorrelated, not necessarily independent. We may or may not be independent. We have no idea. Now, if they are not uncorrelated, if we know they are not uncorrelated, they are correlated, they are related. What can we say about whether they are independent or not? Huh? Even they are not independent. أنا بكتب dependent إيش ما نخلطه، إحنا دائما نستخدم independent. النفي comes dependent. However, if they are not uncorrelated, we know that they are related. معناها they cannot be independent. However, if they are uncorrelated, أنا ما عندي أي فكرة whether they are independent. mean or mean. لأنه زي ما قلنا uncorrelated means that the correlation, which is expected value of xy, decouples into the two means. We have no idea whether the joint deviation decouples into the margin one. We don't know. So today, inshallah, we'll build on that and we'll have more examples in this.
Uncorrelated.
Yes, in Gaussian, when we talk about Gaussian, and in next class probably, we will prove that if they are uncorrelated, they are in. So احنا الآن كتبناها لكن انت يمكن to believe me. Next time we'll talk about it. هذا نفس الكلام إيمان. Let's have some examples and then define what we call covariance and related to that correlation. Okay? So the example here, I have random variable x. I'm giving you the expected value of x, the mean, and I'm giving you the. You don't know what e is. And I know that y is a function of x. Like if x is a signal, y is another positive signal, minus 6x plus 22. Okay? So basically, first of all, I would like to find the mean of y, and then I will check whether x and y are orthogonal and whether they are correlated. So to that cover orthogonality, if expected value of x and y decouples into the mean, it means it becomes uncorrelated. So, however, if this correlation equals 0, we call x and y are orthogonal. Right, let's see. So how to find the expected value of y? Substitute, exactly. So basically, we substitute expected value of y. We just put what y is. So instead, we write we write this as expected value of minus 6x plus 22. So we substitute with what y is. Okay? And then we see anything that is constant, we get it out of the equation. We only leave the random value. So the only random thing is the x. And hence it becomes minus 6 because it's constant. We just put it as a product, multiplied with factor, multiplied by expected value of x plus the constant, which is 2. Okay? Now we know I gave you the expected value of x, it's 3. So basically, just put in the math expected value of y becomes. Okay? Now check whether they are orthogonal or not. How to do that? Find the correlation, right? The correlation, by definition, are xy equals the expected value of xy. Well, whatever xy, we have x, however, we need to substitute for y. So this is y. Okay, and then we multiply. And then anything that is constant outside the expectation, anything that is under variable, continues inside. So now when you multiply x multiplied by minus x6, you get minus 6 x squared. So expected value of x squared continues. And we have x multiplied by 22. So we have 22 expected value. Voilà. Now it's minus x. We gave you expected value, the mean squared, we gave it to you. It's equal to 11. So we have minus 6 multiplied by 11, minus 66. And we have 22 multiplied by 11, which is 66. So we know that the correlation between x and y equals 0. What does this tell us about x and y? They are orthogonal. Okay? Are they uncorrelated? We don't know. We need to figure out, check whether the correlation equals the product of the two means or not. If they are equal, uncorrelated. If they are not equal, then they are not uncorrelated, which means that they are not independent. So we got this as 0, and we have already expected value of x 3, expected value of y 4. So 4 by 3 is 12. So they are not equal, and hence they are not. So there is that. If I ask you without doing all this, are x and y without solving any of this, without knowing the correlation, just looking at the relationship between x and y, Are they correlated? Yes. Basically, y is a function of x, is a direct function, is a linear function of x. So you cannot imagine that you have x and y being uncorrelated. Not mine. Because y depends on x. If x is large, y is small, large negative. If x is small, y is small. صح? So clearly x is related to y is related to x through a very direct relationship. So without understanding anything about the correlation, just from this relationship, we know that y and x cannot be uncorrelated. They are correlated. اوكي واضح يا جماعه؟ يعني ممكن اجيب لك سؤال زي كذا ما اعطيك البي دي اف اقول لك والله اديتني figure out whether they are dependent or independent or not. كنت تدرس تشوف صح يمين يسار دور how to find the joint PDF clearly they are not independent. واحد فانكشن على الثاني معناها they are dependent. واحد لهم علاقه قويه ببعض. linear relationship. اوكي يا شباب؟ واضح؟ So we don't only solve without understanding. We need to understand the concept here. طيب, now this was a linear example. Let's talk about general linear example. When you have y equals ax plus b. A and b, any numbers. A and b. Okay? Now, if we would like to calculate the correlation, which is xy, it's expected value of x, and then we put y, right? And when we open up this becomes a multiplied by expected value of x squared plus b multiplied by expected value of x squared. Okay? Now, expected value of x multiplied by expected value of y. We'd like to see what are the conditions in a and b such that x and y become uncorrelated. So expected value of x multiplied by expected value of y, expected value of x is this, expected value of y is this. Now, when we multiply, we get basically expected value a multiplied by expected value of x all square plus b expected value of x. Okay? Now, if we want to have uncorrelated, what does this mean? It means that these two are well, uncorrelated means these two are equal. Equal means x and y uncorrelated, right? طيب خلينا نشوف ايش الكونديشن اللي هنا. If both to be equal, then a must be equal to simply it says that y cannot be a function of x such that x and y are uncorrelated. ما له علاقة ببعض. If x and y are uncorrelated, a must be 0, which means that y is not a function. Y is a constant in this case, equal to 0. If a is not 0, means that y is a function of x, and hence it cannot be empty. واضح شباب؟ تفضل. إذا كانت again هذه تساوي هذه. لا بس هذه يعني الكوفيشنت اللي هو ايه؟ هم ايه؟ انت قصدك هذا يساوي هذا؟ لا هذا expected value of x square هذا expected value of x whole square. لا يعني هذا expected value of x square هذا هو يمين square. يمين square. So basically you are saying if this equals expected value of x squared, right? They are uncorrelated. طيب لا انت الان you need to find the variance will be 0 and hence x is 1. If the variance is 0, x is 1. X is constant. So if the variance is 0, means that x is not undetermined. It's constant. X. Why? Because this leads to variance of x equals. Okay, good. Now, so basically, uncorrelated means that A must be 0, which means that they don't have any relationship with each other. Now, what about the orthogonal? Orthogonal requires that the Rxy equals 0, right? So in order for Rxy to be equal to 0, so this thing equal to 0, then basically equating this, then A over B must be equal to this, which is the expected value of x squared minus expected value of x squared divided by the mean of x. In this case, they are. Ensure that they are. Okay? طبعا you require from here that expected value of x not to be equal to 0, otherwise it will be everything will go. أي سؤال شباب؟ Now let's talk about the central moments. Our central moments, we'll define them, but we will focus on one very specific central moment. بتذكر moments around the origin, we talked about m n k, right? Which was expected value of x to the power n, k to the power, y to the power k, right? We said that this is the one of the moments around the origin with order equal n plus 2, right? And the most important one was the expected value of x, y, which is the equal to a. Now, similarly, we talk about the joint central moment. Central means that when we subtract the mean of x and the mean of y before raising to the power, before going to the power n to the power 2. Similar to what we have done in the central moment for x only. We define the central moment for x, not for the one only. It was, mu we called it, which is equal to the expected value of x minus x mean to the power n. This was the nth central moment for x. Here now we have x and y, so mu nk, which is the expected value of x minus x mean to the power n, multiplied by y minus x mean to the power n. This is one of the central moments. And the way we calculate it is, this is the general, is x minus x mean to the power n, y minus x mean to the power k, multiplied by the joint and integrate. And for discrete, we have summation over xi, summation over yj, and we have here xi minus the mean to the power n, yj minus the mean of y to the power k, multiplied by the probability of xi yj. Right? This is the general thing. Now, if we take specific examples for n and k, what do we have? For n equal to and k equal 0, so we have mu 2, 0. So in this case, we have expected value of x minus x bar to the power 2 multiplied by y minus y bar to the power 0. And hence we get basically the y bar cancelled. And what do we get? What is this? Okay, so the joint moment when k equals 0, so the joint central moment when k equals 0 gets you the variance of x. Similarly, when n equals 0 and k equal 2, we get the variance of. Now, the most important joint central moment is when n equal 1 and k equal 1, which is now we call it as the covariance. Which one؟ لا هذه covariance. تكلم عن هنا انت الان؟ هذه الفاريبلز اللي قبلها كانت expected value of x multiplied by y سميناها correlation. هذه
بتكلم عن x سكوير
expected value of x squared.
هذه ما هي نفسها من x سكوير؟
لا هذه اسمها ايه؟ second one mean square value. mean square value. لا يسموها mean square value RMS value. mean square value. Okay, this is not the mean square. This is not the mean square. طيب الآن نرجع لهنا. So we call this the covariance. لو تتذكروا ال expected value بس عشان نربطهم ببعض RxY. What was it? Expected value of xy. We call this as correlation, right? Correlation, because it gives you how related the two random variables are. This we call it covariance, because it comes from the equations of the variance. It's x minus x bar, y minus y bar multiplied with each. However, they are not a variance, it's a covariance. Which means that العلاقة variance because we are always subtracting the mean from here. Okay, this is denoted as CXY. هذه كانت RXY correlation. The covariance is CH. Now, what is this? What is? I will say how to calculate it. Can I say why is it beneficial? The way we calculate it is x minus x bar multiplied by y minus y bar multiplied by the PDF and the integral. And if we have discrete, random variables, that will be summation over xi, summation over yj of x I minus x bar, y a minus y bar multiplied by probability of x I yj. So again, it tells you how weighted by the probability of xi and yj, how close the specific sample xi to its mean, how close specific sample of yj to its mean, and then weighted by this. Now, okay. Now, if we expand CXI, just open up without calculation, just multiply the two things together. What do we have here? We have x multiplied by y, right? So the first term would be expected value of expected value of x, y. And then minus. What do we have? X multiplied by x bar multiplied by y minus y bar multiplied by x, right? And then plus x bar y bar. هذا كله داخل expectation. Now let's simplify. What is the expected value of xy? This is the correlation by definition. What is the expected value of x bar y? What is the expected value of x bar y? X bar is constant or random value? Constant. So what is the expected value of x bar y? We have x bar, y bar. Right? What is the expected value of x, y bar? Another same thing. X bar, y bar minus, right? And what is this? Y bar, x bar, y bar, positive. So we have here two negatives of x, y, y bar, and one positive. So what do we end up with? Only one negative. So basically, the expected value of the covariance equals the correlation minus the product of the two means. زي لما طلعنا الفاريانس، لما حسبنا الفاريانس بتتذكروا سيجما اكس سكوير، لما فتحنا simplified, we ended up with expected value of x squared minus x bar squared. تتذكر صح؟ Similar thing here we did. So now we have the covariance equals the correlation minus the product of the two means. So now if we have, what is the condition on the covariance to have uncorrelated random values? When x and y are uncorrelated. When rxy equals the product of the two means. So when this equals this, what do we get as the covariance? So zero covariance means that the two random values are uncorrelated. Okay, so if x and y are uncorrelated, means that cxy equals. Okay, if they are orthogonal, then the correlation becomes zero, huh? Which means that the covariance equals negative of the product of the two. Okay, if one of them has zero mean, then basically the covariance will come. تمام، واضح الفرق بين الكوفيرينس والكورليشن. فرق ان احنا هنا we are comparing x, every value of x with its mean, and every value of y, and we see how far they are from the mean. And when we do the averaging over the different values, we end up with what we call the covariance. And when we open up the covariance, it's equal to the correlation minus the product of the covariance. And in order for two random values to be uncorrelated, we need to have the covariance equals. لا هتكلم عن نقول graphically how. بس خلينا أول شيء we define something more. We have just generalization. If you have joint central moments, we call it mu n1 into blah blah blah, which is expected value of x1 minus x1 bar to the power n1, x2 minus x2 bar, blah blah blah. Now let's go to what a very important coefficient, which is the correlation coefficient. Now, if the correlation is large, means that x and y are high level. If it is large, negative numbers. Like large, it means that x and minus y are highly correlated. So if it is around zero, we say that they are slightly correlated, maybe uncorrelated. Okay, now, so basically, how large and how negative large is large and how small is small? Well, it depends on different parameters. So we need to do what we call normalization. Okay, so let's normalize the second one. What does normalize mean? نتذكر ايش كانت الكوفيرينس؟ CXY. And by the way, we call it covariance. Between x and y. نتذكر الفاريانس نكتب variance, right? Variance sigma x squared. In many cases we call it variance. That's just an indication. Okay. So covariance between x and y. In many cases we write it as cov. مو COVID. Oh. Short for covariance. بس الآن هذه عبارة عن ايش كانت؟ Expected value of x minus x bar, right? Y minus y bar. لو تتذكروا في الراندوم في الجاوسيان راندوم فاليو, in order to normalize our Gaussian random value, what did we do? We subtracted the mean and divided by standard deviation. So similarly here, instead of defining the covariance, we define what we call the correlation coefficient. عبارة عن expected value, نفس الكلام حق الcovariance, however we divide by the standard deviation of x and we divide by the standard deviation of y. Okay. Now if we do this, هذا عبارة عن ايش؟ النيوميريتور expected value of x minus x bar multiplied by y minus y bar. Isn't this equal the CXY? صح؟ Numerator only. Divided by sigma x, sigma y. This is called the correlation coefficient of x and y. And the nice thing about it, because it is normalized, لو تذكروا في Gaussian random variable, when we normalize, we ensure that the variance of the new random variable normalized equals 10. 1, صح? And because of that, this correlation coefficient cannot exceed -1, and it cannot exceed 1. It's between -1 and 1 because of the normalization. Okay? So note that it is basically between -1 and 1. So now, if I have two random variables that are highly correlated, what do you expect rho to be equal to? قريب من 1 or close to 1, صح? If x and y, if x and negative y minus y are highly correlated, what do you expect rho to be? -1 or قريب منها. X and y are uncorrelated. This will be around 0 or 1. واضح? Now this doesn't depend on what x and y, the specific random values. No. Close to 1, it's highly correlated. Close to -1, it's x and negative y are highly correlated. Close to 0, uncorrelated. أو يعني correlation قليل. واضح? So let's write this down. So rho around 1 means that x and y highly correlated. Rho goes close to -1 means that x and negative y واضح؟ highly correlated. Rho close to 0 means that x and y slightly or very close to uncorrelated. Slightly uncorrelated. Slightly correlated. Rho equals 0 means what? X and y uncorrelated. واضح شباب؟ Okay.
Now the rho -1, either x or x minus x and y and x minus y.
واحدة منهم يجي. يعني basically باختصار اثنينهم ماشيين مع بعض لكن واحد ماشي مع نيجاتيف. اوكي؟ يعني واحد يزيد بالبوزيتيف الثاني يزيد بالنيجاتيف. لكن اثنينهم يزيدوا. اوكي؟ Now, what does let's go back to the scatter plot. The vector scatter plot. When I have x and y, I do many measurements and I plot. هذه مثلا x وهذه y. And every time I take the measurement, ايش هيطلع لي؟ One value for temperature, one value for pressure. Right? I just plot it. مكان الفاليو حق الاكس والواي. I take another measurement. I do it. I take another measurement. I do it. Okay? This is what we call scatter plot. Let's start the quiz. And next time, shall we something in this session? You don't have to show you.